In the last lecture, we have already studied how to convert epsilon NFA to its equivalent NFA, and in this lecture we will be seeing another example of the same. So here is the question that we have: convert the following epsilon NFA to its equivalent NFA. We have an epsilon NFA given here, and we know that this is an epsilon NFA because there is an epsilon symbol used, and our task is to convert this to its equivalent NFA. So here we will draw the transition table for the equivalent NFA. So I've already drawn this table here so that we can fill it up right away, and the procedure for converting an epsilon NFA to its equivalent NFA was discussed in the last lecture, so we'll follow that. We have to find the epsilon enclosure and then the input symbol and then the epsilon enclosure for each states, and then we have to fill up this. So let's start with state A. Let's see what will be the equivalent value for input 0 in the NFA. So here we come to state A and we have to find the epsilon enclosure of state A. What is the epsilon enclosure? A on epsilon goes only to A itself, and on 0 where does A go? It goes to B. And then the epsilon enclosure of B. Epsilon enclosure of B is B itself and also C. B and then C, because B on epsilon can go to B itself and also it can go to C. So we get the states B and C at the end. So that means A on input 0 will go to states B and C. Now let's see on input 1. A on input 1, what will happen? We have to find the epsilon enclosure of A, which is A itself, and A on input 1, where does it go? A on input 1 does not go anywhere, so it is 5. So since it is 5, here also it will be 5. That means A on 1 will not go anywhere in the NFA. Now let's come to state B. B on epsilon closure. What is the epsilon closure of B? B and C. B and C. Now B on input 0, where does it go? It goes nowhere. It goes to 5. And then C on input 0, where does it go? It goes to C itself. And now we have to find here, this is 5, this will also be 5. And now C's epsilon closure. C's epsilon closure is only C. So we get C at the end. So B on input 0 will go to C. Now let's do the same for input 1 for state B. Epsilon closure of B is B and C, and B on input 1 it goes to B itself, and C on input 1 goes to D. Now epsilon closure of B. Epsilon closure of B is B and C. B and C, and then epsilon closure of D is only D. So at the end we are getting states B, C, D. So B on input 1 will go to states B, C and D. Alright, so let's come to state C now. On input 0, so we have to do the epsilon closure of state C, which is only C, because C goes only to C itself on epsilon. And then on input 0, where does C go? C goes to C itself, and again the epsilon closure of C will be only C. So it is C that we get at the end. So C on input 0 will go only to C. And let's see what will happen. C on input 1. C's epsilon closure is C. C on input 1 it goes to D, and D's epsilon closure is only D. So we are left with state D. So C on input 1 will go to state D. And let's come to state D now. D's epsilon closure is only D, and D on input 0, where does it go? Doesn't go anywhere. So it is 5, and since this is 5, this will also be 5. So D on input 0 doesn't go anywhere. And then let's come to D on input 1. D's epsilon closure is D itself, and D on input 1 goes nowhere. So it is 5, and since this is 5, this will also be 5 over here. So this is also 5. So now we got the transition table for our NFA. So let's try to draw the transition diagram. And before we draw the transition diagram, let us try to know what are our final states. So I already taught you in the last lecture that any state that can reach the final state only by seeing the epsilon symbol can be a final state. So here let us check for state A. A cannot reach D just by seeing epsilon. What about B? B on epsilon can come to C, but it cannot go to D after that by seeing only epsilon symbol. So B is not a final state, and C also just by epsilon it cannot reach D. So C is also not a final state. So the only final state is D, which was there in the original epsilon NFA. Okay, now let us draw the transition diagram over here. So I have states A, and A is my initial state or starting state, and we have state B, and let me put state C over here, and state D is here, and D is also my final state. So let's see. A on input 0, where does it go? It goes to B and C. So A goes to B, and also it goes to C on input 0. Okay, and then what about A on input 1? A on input 1 does not go anywhere. And let's see B. B on input 0, where does it go? It goes to C. B on input 0, it goes to C. And on input 1, where does it go? B goes to B itself, C and D. So B goes to B itself, and it also goes to C, and it also goes to D. This is on input 1, 1, 1, 1. Alright, now let's come to state C. C on input 0 goes to C itself, and C on input 1, where does it go? It goes to D. C on input 1 goes to D. And D on input 0 and 1, it doesn't go anywhere. So this is the complete NFA. So here we have successfully designed the NFA for the epsilon NFA that was given. So I hope this was clear to you. Thank you for watching, and see you in the next one.